Hey, g'day, it's Prezzo. Thanks for stopping by. Now this is part 5 of building a 4-facet drill grinding machine. There's a playlist and the link's up above there now. You can go back and check out the previous episodes if you haven't seen that. And I'm going to get back onto this project today. I had a bit of a break for around about a week while we did some renovations and repairs around the house. But back into it now, and we're going to get on and do the traverse mechanism for the carriage today, and also go ahead and mount the motor. Now I didn't get a video out last week because of those renovations we were doing, and they were mainly inside the house. I decided that I wanted to convert some of the decorative elements inside the house to more Edwardian or early Art Deco elements. Now the house itself was built in 1990, but it's a replica of a style of house that would have been built around about 1920 to 1930. And this style of house is called a Queenslander. They are high-set houses with very tall ceilings, and they are generally all made of wood. So weatherboards on the outside, all timber elements on the outside, and the interior walls would have been done with a type of paneling called VJ paneling, or a type of tongue and groove paneling anyway. And the particular elements I wanted to do were the fan lights over the bedroom doors, and also a room divider between our hallway and the family room. Now those elements were put in 1990, and back at the time we were in love with this Victorian style, but then we realized that it wasn't correct for the period. So what I've done is taken out the laser cut plywood panels over the doors and replaced those with individual battens. Now the decorative elements in those battens were done on my laser cutter, and with the room divider we just simply made thicker versions of those. So all of that's done now. It's just sort of waiting for paint, but there was a lot of work, just a lot of fiddly work, and I had a bit of an accident. Old Muggins here was standing on a short step ladder, and I stepped off it into thin air. I wasn't looking at what I was doing, and fell back against our television. So I turned a flat panel TV into a curved screen TV. Now the insurance company refused to pay up, so we just went and bought a brand new TV, and I learned a very valuable lesson about clearing this workspace before you get started on a project like that. Now I wasn't injured. The television took the brunt of the fall and absorbed all of the impact, but yeah, some interesting words were said when I realized what I'd done. Anyway, getting on to this project here. Now let's have a closer look, and we'll talk about this traverse mechanism, and then we'll look at what's going on with the motor and the spindle. Here's a good look at what we're doing today, but I did make some of these parts off camera because a lot of what's going on below this piece of V-slot, which is going to be the traverse mechanism for the carriage, is unique to the machine that I'm building. If you're making one of these, you're probably not going to do this, so I just went ahead and made these parts. I did make this little support for the lever, and I've made the lever and this much of the link anyway. And I did all of these parts on the milling machine, drilling the holes and rounding the ends. So let's have a quick look at how I got to this point. A lot of the footage that I shot making both the lever and the linkage was pretty awful really. Didn't frame it up very well, but essentially it's just a lot of spot drilling and reaming and cutting threads. I think the more interesting procedure was rounding off the ends of both those parts. So let's have a quick look at that. This is the setup that I'm going to use to radius this end of the arm, or both ends of this arm, and also the connecting rod. So these are the little DIY Mighty Bite clamps that I made a couple of episodes ago. And these are 2 fixed stops. This is the only adjustable stop here. And I put a brass jaw on this one. That gives you 3 points of contact, which should be enough. Now that part's a little bit flimsy, so I'm just going to go fairly lightly on the cuts, but I'm pretty sure that'll be okay. So I put a pin in the spindle of the milling machine, and I lowered that down until I had the pin in that 6mm hole, and then I've offset 6mm, which will be the finished radius, but I'll actually go more than that to start with to knock the corners off. And although that seems a little bit flimsy, you just got to be realistic, keep your cuts light, and it should be fine. A lot of people have asked about the geometry of this clamp and whether there's anything to stop that brass jaw moving upwards during the cut. And I sat down and thought about it, and I realised that there's a lot of friction there. The chances of that slipping upwards are going to be pretty slim. you're going to have to be doing something pretty bad for that to move. But also because of the 10-degree slope, it really can't move exactly vertically. It would have to move at a 10-degree angle, and that would actually make it bite harder into that part. So in a way it sort of grips itself, and although you can't bottom that screw out with the jaw tight against the metal part of the stop there, or the steel part, I still don't think that's going to move. But I don't know, people who bought commercial versions of this Mighty Bite clamp system would probably know that better than I. Anyway, go ahead and I'll do this one radius, all the others are going to be the same. Okay, that's the finished radius done. Now it's not brilliant, it's got a bit of a hard edge on this side and I cut in a bit too far on that side there, but that will blend in okay with the Scotch-Brite wheel. I probably should have set up the dowel pin in a collet instead of just a drill chuck. That could be one reason why that's not completely centered, but for what it is, it's fine. So the next step here now is to slot both ends of this link here. Now this material is 4mm thick and the carriage plate is 3, and unfortunately I don't own any metric slitting saws, so I'm going to have to use a 3/32 slitting saw, and it will mean that it's going to have to do a full width cut and then a partial cut, which is not ideal because when you do the partial cut it will deflect slightly. So I'm just going to have to shoot for a little bit oversized and hope that that will work. Now at the end of the day this thing is just moving very small amount and it's not under any great load, so I think we'll get away with it. So we'll go over to the mill now, get this set up in the vise, and we'll do the slots. The slot that we're doing here has to be 15mm deep, so I'm just using my rule to make sure I'm not going to run into the vise jaws. And we're going to lower the slitting saw down onto that surface there. I've just taken the milling machine out of gear and you can sort of rock the cutter backwards and forwards and you can sort of feel when it's just brushing the surface there. Now at that point I'm going to lock the quill, I'll set my DRO to 0, and then we're going to offset the thickness of the slitting saw, which is 2.38 or 3/32 of an inch, and then I've got to offset 3.4mm to get the top side of the slot, and then another 0.72 to get to the bottom edge of the slot. Okay, that should be the top edge of the slot. So I'm going to take this in, well I think I'm just going to feed straight in from the end and then I'll just traverse backwards and forwards. I don't know, sounds like a good plan. Now, I'm fairly sure that deflected a fair bit, but that's a 3mm drill bit and that fits in there quite easily, so I think we're okay with that. So I'm going to flip this around now and do the other end. So same deal here, just slightly different offsets. So I'm just bringing the table or the knee up now, and that's scuffing on the surface there. Alright, so we'll zero out Z there, and then we just got to go, yeah, slightly different offsets. Okay, so that's the depth for our first cut, and this one's going to wind up 4mm, or actually 4.1 wide. That sort of came very, very close to my vice jaw there. We got away with it. So that's the lever, and that's a sort of a nice sliding fit there, so that's good. Well, there's the lever and the linkage assembled onto the carriage plate now, and you see how that's going to work. So this will give you some control over the position of the drill bit relative to the face of the cup wheel. Now these screws are only temporary. At the moment the threaded portion of these screws passes through the holes in the lever and the carriage plate, which is why you get that little bit of movement there. I'll replace those with some custom made screws later. Now the next most important thing is to position the grinding spindle, and therefore the face of the cup wheel, in a very, very precise position. Now the face of the cup wheel has to be aligned exactly with the center between these two trunnion bolts, and that's absolutely key in this design. Just to give you some sense of how this is going to look on the cab model, here is a view of the trunnion, and you can see that as we pivot the trunnion up and down through the range that you would use to set the primary and secondary angle on the lip of the drill, the axis of the drill bit always passes exactly through the center of the axis of the trunnion itself. Now here's another view from the CAD drawing looking down from above, like a plan view. And you can see a line which passes through both ends of the trunnion, has to coincide exactly with the face of the grinding wheel. Now in the notes that John Moran wrote for the construction of this tool, he suggested using a piece of precision ground drill rod like this, and then to mill away exactly half the thickness of that diameter, and use that in place going through the centers of the uprights on both ends of the carriage, and then pushing the face of the cup wheel up against those flat surfaces there, and that will give you the exact position for the face of the wheel, and therefore the mounting position for your grinding spindle. Now in reality you need a flat around about here, somewhere halfway between these two uprights, and another flat on the outside of this rod here. So I'm going to mark those positions roughly on a piece of this drill rod. We'll go over to the mill and we'll cut away that material and then use that tool. Now here's another view taken as a plan view down on top of the CAD drawing, showing that tool in position, and you can see how that's used to position the face of the cup wheel. So let's go over to the mill and let's make that tool. So here's how this is going to work. I've got a sort of a shop made V-block here. This is just a piece of aluminium stock, and I've milled a 6mm groove in there and just put a very small chamfer on the edge. And that's going to allow me to hold that piece of 8mm drill rod into that slot there with a couple of toe clamps. Now the area that I've hatched there is what I need to mill away to half the thickness of the stock, and those flat surfaces will go up against the face of the cup wheel. So I'll get all this bolted down, we'll mill away that stock and see if we can position the spindle semi-accurately. There is some adjustment built into the setup though. I've got all that clamped down now, and I've left this end sticking out so I can get a micrometer on there and check the half thickness of that stock there. So I'm just going to edge find against that face. It's not super critical where these cuts start and finish, but might as well do it to the drawing that I produced there. So I'll get it set up now, and then I'm going to use a 10mm carbide end mill to just whittle away at that material, and when we get close I'll put a micrometer on it and check it. Okay, I'll put the cutter in, and on the DRI I'm just going to set the positions of the finish for this first cut and start and finish for the second cut. Okay, we'll just get a reading on that. I'm only just going to make this, I think. So according to the micrometer we got 0.33 to go, and that should bring us to our target depth of 4 millimeters. Okay, we'll get that out of there and deburr it, but that should give me my flat surfaces now to put up against the face of the wheel. What I've done here is I've taken the trunnion plate out of the carriage, and on the steel base here I've got a scribe mark. Now I've positioned this from the CAD model that I've already got, and this will be the extreme right hand edge looking from the front of the machine of the circular base of the column. And here's the part that we just made, and this can go through the vertical uprights on the carriage plate. And I can position that with the flat surface that we milled facing towards the diamond wheel. So when I place the grinding wheel against that mark, and then we can move the carriage plate across and then bring the face of the wheel in against that flat surface there. So if we come into roughly that position there, I can mark on the steel base where the bottom of this column will be. So I'm just going to use my marker pen here. I'm just going to mark around the base of that column. Now at the moment, nothing needs to be terribly accurate. It's when we do the final setup that we've got to get it absolutely right. So, don't know if you can see that, but I've got a mark there, and I'm going to locate the approximate center of that. That's when we mill that slot, and then we can do this whole setup again, but do it super accurate. So I've just taken the column out of the grinding spindle, and this scribe mark here is the edge of the circular profile. So what I need now is a center line, and I've got that set up on my marking gauge. So I'm just going to scribe a mark there, and that's going to be the center of our milled slot. And you see that in the base of the column there I've already drilled and tapped, and this is our threaded fastener and the washer. So this is all going to get clamped up from underneath that steel plate there. Alright, there's our centre. What we need now is an 8mm wide slot and around about 3mm either side of centre, just to get the adjustment that we need at the next step. So here's our steel plate now, bolted down to the table of the milling machine. I've got a centre finder directly over that centre punch mark, and I've made sure that I'll be milling within the boundaries of the T-slot here. So I'll get an 8mm end mill set up now, and we'll just cut that slot. Now I did machine that slot a little bit wider. I said 3mm either side, I actually went 5, and that's because I've just taken delivery of a CBN wheel for this grinding machine, and it's a little bit different in its dimension. So this will just give me a little bit more movement to accommodate for that. I've just done a partial reassembly on this now, and there's the slot that we just made. And what we need to do now is to mount the column which supports the grinding head. So we're going to put this 8mm countersunk head screw up from underneath with the big washer underneath as well, and then we've got to get this aligned correctly with the face of the tool that I just made, the alignment tool, this one here. So I'm going to get that in position, but just off camera I made a couple of these hex-headed bolts, and these have got a plain section that fits through the linkage, and with that in place now we get a nice positive motion from that lever there without any looseness at either end. So now all that operates beautifully. So I'm going to put the setting tool that I made in place here now. Now it's a bit fiddly. You've got to get this through using the full diameter. When you get to the half diameter it wants to catch. So I'm going to mess around off camera. I'll get this set up and we'll come back. So I've got that setting tool in position now, and I've put the socket head screw up from the underside of the base here, and what we can do now is just lightly assemble that column into place. So that's free to move backwards and forwards in its slot now. Now on the grinding spindle itself you'll notice that I've removed the motor, so I've just got the actual grinding head itself. And there's the CBN wheel that I just took delivery of. Now this is an 80 grit. I'm starting to think that that's probably too coarse for the smaller diameter bits. I might need to get a 120 grit cup wheel for that, but for now this will be fine. I can always swap back to the diamond wheel just in the short term. So what we can do now is assemble that onto the column and just get it roughly in place. Right, I'm just going to lock that there, and I'll bring it around the other side so you can have a closer look. So this is what it looks like now, and you can see that you can pivot the whole grinding spindle, but you can also move the spindle laterally, and the trick is to bring both sides, both surfaces of the wheel up against the two flats we made on that tool there, and then you've got to reach underneath and try to tighten the screw. Now I've already tried this previously, and I can tell you now it's not easy. You've got to sort of do it in stages, go backwards and forwards as you tighten the screw, and then check. You can do that by just lightly rotating the wheel and just listening. You can hear whether it's touching one side or the other. So I'm not going to try and do it on camera. I'll get this done and bring you back when we got it ready. Okay, that took about 3 or 4 minutes of messing around to get that right, and I can rotate the grinding wheel now, and I can hear that it's touching on both sides, and if you look down there with a strong light you can see that it's pressed up hard against the two flats. Now the good thing about this Quorn grinding head is that it does have some adjustment. So there are 2 screws on the casting here which you can't see. I've slackened those off, but you can move the whole spindle through that casting, push it up against the flats on both sides of that tool there, and then lock those screws. So you can get some adjustment without having to mess with the position of this column. Now that keyway there is not used in this application. I should have aligned it correctly, but this is all going to come apart for powder coating and anodizing anyway, so I'll address that when I put it together for good. So I guess what we need to do now is remove this bar, the setting tool, and put the trunnion back in place and see if we can grind a drill bit. Now I should have mentioned there's only one problem here. You can't get that setting tool out of the 2 uprights without removing the whole V-slot assembly here. I can't slide it out because the grinding wheel's in the way. I can't remove the grinding wheel because it needs to move out in the direction of the setting tool. So what I have to do is loosen these screws holding the V-slot down and just push it out of the way temporarily, and I'll get that tool out of there. But we'll come back when I got that done. Well, that is a 23/64 Imperial twist drill. It's an old one that I have in a set. I don't think it's ever been sharpened, and it's only the second drill bit that I've sharpened with this machine. And why did I go ahead and do it without you? Well, I didn't want to make a fool of myself for a start, and it takes a while to get used to the workflow and you get used to the process. Now this one's not perfect. There's a little tiny imperfection on the end of the drill bit there, but I'm fairly confident this would cut really well. And I did sharpen another drill bit and try it out in some steel stock, and it seems to be going quite well. So I'm just going to reposition the camera and we'll look at the machine up to this point, and I think that's the end of today's video. I was hoping to go through the whole workflow from start to finish, but it turns out that there are a few accessories that I need to set the drill bit correctly, and I want to have a bit more practice with it before I sort of show you in detail. But let's have a look at the whole machine. Okay, just before we finish up, I want to show you that drill bit there. That's the first one that I did in the machine, and it's not perfect, and it's going to take me a while to sort of get the workflow dialed in, but I did try that out on a piece of steel bar stock, as you can see there. I drilled those 4 holes with no center punch mark. It just started quite readily, and the drill bit itself is a nice snug fit in that hole there. So it certainly hasn't wandered, which is what tends to happen if you offhand grind a drill bit on a regular grinding wheel. If you don't get the 2 cutting edges exactly the same length, it will orbit around and tend to drill an oversized hole. But that seems to be quite good. Now in the one that I just did, that you saw me do, again, it's not perfect, but for a first or second attempt I reckon it's not bad. What you will notice though is that I accidentally ran the collet nut into the edge of the grinding wheel. So when that's in place there, you start with the drill bit off the outside of the circumference of the wheel, and you can run it into the wheel like that. But if you go too far, you will make contact with the edge of the wheel and the face of the nut. So we're going to need either a stop to prevent that happening, or the other option is to make a custom nut with more clearance on the end, which is something I may do. So for now, I'm just going to live with the fact that I've ruined that collet nut, or marked it anyway. I can easily get another one. Okay, next thing, we need to be able to set the primary relief angle under the trunnion here in some easy way. Now there is a table. John Moran has made this available on his website, and I've just laser cut this from some 2-ply plastic, and this gives you the relationship between the size of the collet, or the inch diameter of the drill bit, or a particular drill number or letter size, and the relief angle. So the one that I just sharpened that you saw me do, I was using a 9mm collet, and that meant that I needed to have a relief angle of 12 degrees. Now that same relief angle will work for a drill diameter, an inch diameter of 354 thou, or it would work for a letter S drill bit, or letter S drill bit, sorry. And if you go down to say something like a 3mm collet, you would need to use a primary relief angle of 18 degrees. Now eventually I will engrave the face of this eccentric wheel with those positions, but for now what I've done is I've just laser cut some templates. So for the 12-degree primary relief angle, which is what I just used, you can slip that underneath the trunnion plate and then lock the eccentric wheel in that position. And I've done these for all of the relief angles that it shows on that chart. But that's just a temporary measure, and also a way of actually setting up the trunnion plate so we can work out where the engraved marks need to be on the eccentric wheel. Now the other thing is my drive belt decided to self-destruct. So this was the one that I was using. This was originally on the Quorn tool and cutter grinder. This is a urethane belt. The actual product name is called Roundthane, R-O-U-N-D-T-H-A-N-E. It's a hollow cord belt, as you can see there, and it's got this little aluminium joiner which just simply plugs into the hole. Now the only problem is this stuff goes brittle over time, and I shortened this belt because it seemed to be a bit long, put it on the machine, and then the next day it was snapped through. So it actually broken, not at where the joiner is, it broke somewhere else. So I've ordered some more of this material. What I've got there at the moment is just a big O-ring, and that seems to work, but it's only temporary. Now the other thing is, you'll notice it's rubbing on this locking lever here. That locking lever should actually be on the other side. I just put it together wrong. I'll fix that when I strip all this machine down for finishing and reassemble it. But for now it seems to be working quite well. Now the motor on this machine is reversible. So there's a toggle switch there. If I flick that over the other way, we can run it in the opposite direction. Now John Moran suggests that this grinding process works better when you're actually grinding onto the cutting edge, not off the cutting edge, and that way you don't leave a burr on this edge here of the drill bit. Now I can reverse it, but just for today I ran it in the opposite direction with the grinding wheel running off the cutting edge. And when I get my 120 grit cup wheel, this is an 80, I think it's probably too coarse, but when I get that, I think I'll run it in the other direction, see how that goes. So for now it's sort of working, but what I need to do is practice a lot, and I also need to make some other accessories for this which I just didn't get around to. Now one of them is a tool that allows you to set the 2 cutting edges parallel to this base here, and I've sort of partly started that. So I laser cut this little screen here with a scribe mark on it, and that's going to go on a block, and then you just simply sight through that scribe mark there and align the cutting edges of the drill bit with that. For now, I just use a rule and I line it up along those cutting edges and just did it by eye. And that seems to work, but I think it'd be better if we had a dedicated jig for doing that. Now there's also another jig that allows you to do split points on this machine, and I haven't even looked into that yet, but it tilts the whole collet block up at an angle like that, and you can run that onto the cutting wheel or grinding wheel, and that will do the split point geometry on the end there. So unfortunately, like I said, I've run out of time today. I'm not going to get through everything I hope to do, but we'll do that in the next video, so please join me for that. By the time this next video comes out, I'll be an absolute expert. And we'll also look at some of the finishing process. It may actually blow out to 2 more videos, I'm not sure. Anyway, thanks for joining me today. I'm sorry I didn't get through everything I hoped to, but well, yeah, more videos for you to watch. So it's Presso signing out for now. Thanks for watching today, and I'll catch you next time. Cheers.